Have you ever wondered about the best way to manage memory in C++? It's a hot topic, especially when comparing RAII to garbage collection. Today, we're diving into this debate and exploring which method might be better for you. I totally get it. Memory management can be a real headache, especially when you're trying to avoid leaks and crashes. You're not alone in this struggle. Many developers face the same questions. Here's the specific question we're tackling today. One user recently asked about the differences between RAII and garbage collection in C++. They want to know if strictly following RAII is really any different from using a garbage collector. Sound familiar? Let's break it down. So what exactly is the difference? RAII, or Resource Acquisition Is Initialization, gives you full control over resource management. On the other hand, garbage collection automates this process, which can sometimes lead to more efficient memory usage. Let's explore both sides. And stick around. By the end of this video, you'll have a clear understanding of which method might be best for your projects. To understand the difference between RAII and garbage collection, the user should first recognize that RAII stands for Resource Acquisition Is Initialization. This means that resources are tied to the lifetime of objects, ensuring they are released when the object goes out of scope. Next, the user should consider that with RAII, the programmer has explicit control over resource management. This allows for predictable and efficient resource usage, as resources are released immediately when they are no longer needed. In contrast, garbage collection operates automatically. The user should note that while this can simplify memory management, it may introduce unpredictability. Garbage collectors run at intervals, which can lead to delays in resource release. Additionally, the user should be aware that garbage collectors can sometimes be more efficient in managing large memory allocations. They can free larger chunks of memory at once, which can be beneficial in certain scenarios. Ultimately, the user should weigh the benefits of control with RAII against the convenience of garbage collection. Each approach has its strengths, and the choice depends on the specific needs of the project. Fun fact: did you know that the concept of garbage collection was first introduced in the 1950s? It's been evolving ever since. Now, let's look at the answers provided by other users. The user explains that the term efficient can mean different things. In terms of development effort, RAII is often less efficient than garbage collection. However, for performance, garbage collection is usually less efficient than RAII. They also note that there can be exceptions to both cases. For instance, using generic garbage collection can be challenging when resource allocation patterns are clear. Similarly, using shared pointers excessively in RAII can lead to inefficiencies. Let's take a moment to review another user's answer. The user highlights that determining whether RAII or garbage collection is more beneficial or efficient requires context and definitions. They point out a key conceptual difference. With RAII, resource cleanup is tied to the thread that calls the destructor. In single-threaded applications, this can lead to inefficiencies as one core handles cleanups. In contrast, garbage collectors often run in their own threads, allowing them to operate independently from the main program execution. Now, let's see a response from a different user. The user explains that garbage collection and RAII each excel in different scenarios. Garbage collection is efficient for managing immutable objects, allowing easy reference passing without copying data. However, RAII is better for managing exclusive resources, ensuring timely release of outside services. The key takeaway is that garbage collection handles fungible memory well, while RAII is superior for non-fungible resources. Therefore, a language that supports both approaches would be ideal. Let's take a moment to review another user's answer. This user highlights that RAII, or Resource Acquisition Is Initialization, effectively manages various resources, not just dynamic memory. It can handle files, sockets, and database connections, ensuring they are released deterministically. In contrast, garbage collectors primarily focus on dynamic memory allocations, allowing programmers to concentrate on peak memory usage rather than individual allocations. Let's take a look at another answer from another user. The user explains that RAII and garbage collection address different issues. RAII uses stack objects to manage resources like sockets and files, ensuring they are cleaned up when the method scope ends, which is crucial for exception safety. In contrast, garbage collection manages heap-allocated memory, allowing for persistent objects even after control leaves a scope. While RAII is great for resources expected to be released at method return, garbage collection can handle larger memory chunks more efficiently. Here's a takeaway. If you prefer control and predictability, RAII is the way to go. But if you're dealing with complex systems, a garbage collector might save you time and headaches. And there you have it. Understanding RAII versus garbage collection can help you make better choices in your C++ projects. If you found this video helpful, don't forget to subscribe for more insights and tips.